All right, so remember your test is either next Friday if you're in 5th period, so Friday the 17th or Monday the 20th. So let's get started. So the absolute value, and I move it right 4 and down 2. All right, my slope is 1/2, so I'll be going this way and that way. Okay, a V shape, parabola, left 2, down 3. My parabola shape, I go out 1, up 1, go 2, and then 4. All right, and then if you want to do 3 and 9, but I think this will be good enough. All right, square root, so that's like a sideways parabola, so moved up 2. So it starts here, 1, 1, 2, 4. That's all we have space for. A line starts at -1, goes down 2 over 3. Okay. All right, parabola upside down, a stretch. All right, right 1 up 6. So since we're stretching it, we're going out 1 and we're going 2 away. And then 2 used to be 4, but now it would be 8. So I have to go down 6, 7, 8, so it'll be right there. All right, so you see how it looks skinnier. All right, and less than, so I'm gonna do a dotted, so left 2 and down 3. No slope change, so no stretch, so I'm just gonna draw it normal. All right, and less than, I'll shade underneath it. Okay, so make sure you go back and review your graphs. Okay, in this question here, I'm being asked, when is this function, when is this picture greater than or equal to 0? So my critical numbers are my x-intercepts. That's where it changes from negative to positive. So that'd be -1 and 4. So notice my graph is below, then it's above, then it's below again. So negative, positive, negative. All right, so I'm interested in greater than or equal to 0. So this part, so I want -1 and 4 because it's equal to 0 there, and I want this in between. So I want everything, oops, I forgot my x. So any x that's an element of the set of numbers from -1 to 4 is my solution. Now over here I don't have a picture, so I'm going to go ahead and get everything to one side and factor it. So I'm going to take away 2x squared. So I got 5x squared minus 3x, and then the 2 is going to come over and be -2. So I will factor this to find my critical numbers. So I got 5x and x, 2 go here and there. So 5x and 2x will make my -3x. I want my 5x to be negative and my 2 to be positive. So my critical numbers are 1 and -2/5. So I'll put 1 here and -2/5 there. Now I got a test. So a number before -2/5, like, I don't know, like -10. If you put a -10 here, that's going to be -50 plus 2. That's going to be a negative. So I'll have a negative. And -10 minus 1 is another negative. So negatives multiplied together will be a positive. All right, put a number in here like 0. 0 plus 2 will be positive. 0 minus 1 will be negative. So that'll be a negative section. And everything past here like a 5. So put 5s in there, you get both positives, so you get a big positive area. So I'm interested in the parts that are greater than 0, not equal to. So I don't want these numbers, and I want the positive areas. All right, so x is an element of anything behind -2/5, so -infinity to -2/5, or anything after 1. And there we go. All right, so let's see, down here. System of equations, we're going to do linear combinations. So I think what I'll do is multiply this bottom row by -1 so that this becomes a positive 9. So 2x minus 9y equals -3 stays. This becomes -10x plus 9y equals -21. Now instead of doing this, I could have just subtracted these rows and been on my way, but it's a little easier to see. So I'm going to add these because these go away. So -8x equals -24. So x is 3. So the beginning of my answer is 3. So I'm going to put 3 back in this bottom problem. How about? So 10 times 3 minus 9y equals 21. That's 30. So if I take away 30, that's going to be -9. So -9y equals -9. So y is 1. Okay. Alright, use my calculator to make a plot of the data and determine if it's linear or quadratic. So I'm going to need to look at a picture. Alright, so my x's and my y's. So let me see if I have anything in here. I don't. But if I did, I would do second plus 712 to clear. Alright, actually let me just do that, because I don't know if I have other stuff. Alright, so stat, enter, put my numbers in, 0, 3, 7, 10, 14, 18, 21. Alright, then I got 4, 8, 12.8, 24, 49.2, 87, and 130. Okay, got my numbers in. I'm going to have to do a plot. So second y equals, go there, turn my plot on. I'm going to do zoom 9 to see the picture. Okay, looking pretty curvy here, so I think I will choose quadratic. Alright, so I want quadratic, and so my equation, let's get it. Stat, calculate, let's do number 5. I have to store it, so alpha trace, calculate. So here we go. Y equals point, it says nearest hundredth, so 0.37. X squared, negative 1.98. X and 7.09. So there's my equation. And I want to plug in 30. So I want to plug 30 in for the x's. But I'm not going to plug it into this. I'm going to plug it into the equation on my calculator. Because in y equals, that whole big thing with all the decimals is there. So I don't want to plug it into my equation where I round it off. The best thing to do would be to use my calculator. So I'm going to do alpha trace and grab y1 and plug in 30. So I'm going to say 277.49. Okay, next page. Alright, so let's see. I am solving the system of equations. Substitution is usually best. This is a parabola or a quadratic. This is a line down here. I think I'll just go ahead and solve this for y. I've got y equals negative 2x plus 5. I'm going to take that and put it right there. So negative 2x plus 5 minus 3 equals x squared minus x. So I'm going to want to factor this because I have these x's here. So I'm going to bring everything over to the right because that's where my x squared is positive. So I'm going to add 2x over there. So I got x squared plus x. And then look at this. 5 minus 3 is 2. So I'm going to move the 2 over and put a minus 2. Alright, so everything's equal to 0. Let's go ahead and factor. So you could get problems that require the quadratic formula, but I'm not going to be that mean. So let's factor this. I need 2 and 1 plus 2 minus 1. Alright, so that means the beginnings of my answers are negative 2 and positive 1. Those are the beginnings of my solutions. Alright, so where would I like to plug it in? I think I'd like to use this. Y is negative 2x plus 5. So I'm going to put negative 2 in there. That's going to turn into 4 plus 5, which is 9. I'm going to put 1 in there. So negative 2 plus 5 would be 3. And there's my solutions. Alright, up here we got a parabola or a quadratic and another quadratic. Alright, so it's already set up. I'm just going to take that and plug it right there. So 3x squared minus 11 plus 2x squared equals 9. So that makes 5x squared minus 11. I'm going to add 11 over, so 5x squared. I'm not going to factor this because I don't have an x term. So I can just use square roots. Divide by 5 and square root. So x is plus or minus 2. So let's start my answers, 2 and negative 2. Alright, so where can we plug it in? I guess I'll plug it into this one. So y equals 3x squared minus 11. So I put a 2 in there. 2 squared is 4. 4 times 3 is 12. 12 minus 11 is 1. If I put a negative 2 in there, I get the same answer. 4 times 3 minus 11. So I also get a 1. Okay. Alright, here we go. This is a quadratic and a line, or linear. Alright, so we're going to use our calculator. To use our calculator, I'll have to move that 2x to their side, so it'll be y equals negative 2x plus 1, but this one's already solved. Alright, so here we go. Now, I just did all that plot stuff, so I'm going to use second memory 712 to clear that out. So back in my y equals, I got 2x squared plus 3x plus 1. And then I got negative 2x plus 1. All right, so let's go ahead and graph these and see what we got. Okay, I got two nice solutions there. So remember, on my calculator, I'm going to do second trace, which is calculate. Choose number 5, and then just press enter 3 times. So there's one intersection at 0, 1. And then my other intersection, I do second trace again, number 5, but I got to move the blinker, or the eyeball, closer to the other answer. Press enter 3 times. And I get negative 2.5 and 6. And then just pause and sketch that graph over there. All right, number 14, you got a water balloon catapulted into the air. All right, you got a height after t seconds, so let's draw a little picture. So when I plug in 0 into here, I can see a 2.4 is going to happen. So that's going to be where I'm starting, 2.4. And then, it goes in the air and comes down and splashes or whatever. Okay, so this is my time. This is my height, h of t. This is my height in meters. Okay, my time is in seconds. Okay. Okay, so continue on the next page. How high off the ground is a water balloon when it's released? So we already kind of thought about that. That's h of 0, right? So if you plug 0 in here, you get 2.4. So h of 0 is 2.4 feet, that is, right? Is it feet? Oh, meters. Dang it. All right, how high after 1 second? Somebody wanted to do h of 1. So the formula is negative 4.9 t squared, so 1 squared, plus 27t, so plus 27 times 1, plus 2.4. All right, so pop that in your calculator. So negative 4.9, 1 squared is going to be 1 anyway. Dang it. Plus 27 times 1 plus 2.4. So look, the reason we drew a picture is this. 1 second goes by, where's the thing? So when I get this answer, it better make sense to my picture. All right, so 24.5. 24.5 meters. Higher than when it started, right? All right, at what time does the balloon reach its maximum height? So that's the vertex, that's the x value of the vertex. So it's the x value, which in our case is t, is the negative b over 2a. All right, so negative b. So my b value was 27, so negative 27. My a value was negative 4.9, so negative 4.9 times 2. All right, so let's see, 4.9 times 2 is 9.8. So I got basically 27 over 9.8, right? So 27 divided by 9.8, we'll say 2.76 seconds. Okay. All right, so what's the maximum height? Well, the maximum height is at the time when the maximum height occurred, I have to figure out the height at that time. So I basically want h of 2.76. Right? So I'm doing this, but with 2.76. So we got negative 4.9, 2.76 squared, plus 27 times 2.76, plus 2.4. Okay. And we're getting 39.59. Meters, sorry. All right, when will the balloon hit the ground? So that's the time, the balloon, it's going along, it's going to smash on the ground right there. So it's my x-intercept. So I want the quadratic formula. I need negative b, so negative 27, plus or minus the square root, we'll figure that out, over 2 times a. So 2 times negative 4.9, we did that earlier. It's negative 9.8. All right, so let's figure out my discriminant. So I need b squared, remember b is 27, so 27 squared minus 4 times a is negative 4.9, and c is 2.4. All right, 77 or 776.04. Okay, let's put this in and see what we get. So fraction negative 27 plus the square root of 776 over negative 9.8. All right, so this doesn't make much sense. 0.09, because that's negative. I can't have negative time. So I'm going to go grab it, and I'm going to change the plus to a minus. So there we go. 5 if we round that, that'll turn that to a 6. So 5.6 seconds. It's in the air. Okay. All right. A local music concert venue is actually just a large field where all the customers pay the same price for a concert ticket. The ticket price is $25. The attendance is usually 8,000. So a survey indicated that if you increase the price, the concert goers are going to decrease by 200, so 7,800. And then 27 will be, what's it called? 7,600. Then 28 will be 7,400. Then 29 will be 7,200. Okay? All right, so what's happening here? The number of people attending, it started off at 8,000, but I was taking off 200 for everything above 25. So every number above 25, I want x minus 25 here. Okay, so that's my number of people formula. So 8,000 minus 200 times x minus 25. Okay, so let's clean that up. 8,000 minus 200x, and 200 times 25 is 5,000, so plus 5,000. So that would clean up to be, let's see, 8,000 and 5,000 is 13,000 minus 200x. Okay. Now, my revenue is the number of tickets times the number of people, right? It's like what I'm charging per ticket times the number of people that go. That's what the money I'm gonna bring in. So it's x times n of x. So it's x times, well, look, there's my n of x. 13,000 minus 200x. Okay, so if you wanted to clean that up, it'd be 13,000x minus 200x squared. And if you wanted to write it in standard form, it'd be negative 200x squared plus 13,000x. Okay, all right, so I graphed it in Desmos for you, so you just have to interpret it and be able to write the equations. All right, so there we go. Determine the ticket price that results in the maximum revenue. So there we are at 32.5. $32.50, right? What's the maximum revenue? All right, and there it is. $212, or $212,250. Okay, and so that's basically it. That's all I wanted to know. What price should I charge and how much money will I make? All right, last problem here. All right, I got the good old fence problem. We got 1,600 feet of fencing to use. So write an equation for that fencing. So I got 2 x's and 4 y's. So 2 x's plus 4 y's has to add up to 1,600. I'm going to solve for y. It says to take away 2x. Divide everything by 4. So I think I'm just going to divide it now. 1,600 divided by 4 is 400. 2 divided by 4 is 1/2. Okay, or you could just put a big fraction with the 4 on the bottom. So my area is x times y. Well, x times y turns into x times, hey, here's the y. So 400 minus 1/2 x. So that would be 400x minus 1/2 x squared. And if you really wanted it in perfect standard form, you'd say negative 1/2 x squared plus 400x. Okay, so I've graphed it for us. And here it is, my area, my width of the fence. So this is my x value here. So it looks like the best thing would be to have a width of 400. So 400 feet by, well, now I have to figure out what y is. So basically I have to plug 400, that x value, into here, because that's y. So half of 400 is 200. 400 minus 200 is 200. Okay, and what's the maximum area? Well, that's right on my picture. My area, 80,000 square feet. All right, there you have it. I'll see you next time. Bye-bye.